Now that you know the basics of health index, let's see how it applies to the distribution power system. We should start with most of the utility companies' most numerous assets, which are the power poles. For the assets, we should first look at how does it degrade, and then look at how is the asset being assessed. Afterwards, I will go over the evaluation criteria and then how the health index can be calculated using these criteria. Lastly, I will go over an example to calculate the health index for a particular pole. Since poles is such a critical type of asset, I will spend more time on it, and thus it will be split into 3 videos, namely the degradation, conditional assessment, and then the health index calculations. So let's get started. Now, before moving further, I do wanted to say this as a disclaimer. So the health index weights and its categories that I will be using in this course is actually just a guideline. And these numbers will be different from one utility company to the next. So as such, please consider evaluating the situation before finalizing the weights and the categories used, as some categories may not even apply to your situation, or some where the companies may consider putting more weights forward. Like, there is actually no right or wrong on this. Everything is just a guideline and should be tweaked according to the business needs. Because wood is a natural product, its decomposition differs from that of other assets in distribution system. Biological and environmental causes such as fungal decay, wildlife damage, and weather effects are the most important factors in the degradation of wood poles. Fungi affect wood poles' external surfaces as well as their inside heartwood. And the existence of fungus spores in the presence of water and oxygen is required for the process of fungal degradation. And as a result, the section of the pole most susceptible to fungal decay is at and around the ground line, although pole rot can also start near the top. Before installing wood poles, utilities treat them with preservatives to keep them from rotting. Wood preservatives have 2 purposes. First is to seal the surface to keep off moisture that encourages fungus, and 2, to eliminate fungus spores. External damage to the pole by wildlife, in addition to natural deterioration processes, can be a significant issue. Termites, tiny animals, and woodpeckers are all examples of this. Woodpeckers, for example, are recognized as a severe concern in North America. The bolt holes in poles can be deformed by a variety of factors. In most cases, such malformations cause no immediate concerns. Deformed holes, on the other hand, can cause the structure to fail as well as other components attached to the pole to fail. Bolts can also loosen, elongate, bend, crack, shear, or break, and become lost. Although most power companies are now use fully treated wood poles, this was not always the case. Lines built 40 years ago or earlier may not have been built with fully treated poles, and instead may have used merely butt-treated poles. Fully treated poles are often considered to have a longer service life than butt-treated poles. The following are some of the most important elements that affect wood pole strength as they age, as shown in front of you right now. So they are, for example, the original wood pole type and class, the wood flaws, such as if there's any knots, fractures, or rot, the rate of service life deterioration, which is affected by the type of treatment and environmental circumstances, any signs of a woodpecker, bug, and other wildlife damage to poles, and lastly, the natural wood property that that wood is combustible. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. But wood is not the only pole type used in the utility world. Now moving on from the composite poles, we have the steel poles, and steel pole corrosion is a challenging problem to handle because it occurs largely beneath the Earth's surface. And in many circumstances, a visual inspection is impossible to accomplish because the corrosion occurs below ground level. Steel poles deteriorate owing to corrosion beneath the surface or problems with the coating. And as a result, the most effective method of evaluating below-grade degradation is to excavate a portion of the surrounding soil to conduct a visual assessment. As for crossarms, a decline in strength owing to wood rot caused by moisture infiltration is one of the degradation mechanisms for wood crossarms. Rusting reduces the strength of steel crossarms and hardware, on the other hand. Now, last thing I want to say about crossarms is that aside from rotting or corrosion, wind and ice storms can also cause damage to these crossarms and as well. And these are actually affecting both wood and steel crossarms. Now, before ending this video, I want to briefly talk about insulators that are on poles. Now, dead-end suspension, post, and pin types insulators and configurations are commonly employed in distribution systems. Porcelain or polymer may be used as the insulating material for these insulators. Zinc-coated ductile or malleable iron is commonly used for the metallic components, and insulators are susceptible to both electrical and mechanical stressors. The loss of either dielectric or mechanical strength would cause degradation and eventual failure. Mechanical pressure on suspension and line post insulators is caused by a combination of tensile, torsional, cantilever, vibrational, and compressional forces caused by conductor vibration and galloping. High-density snow or ice accumulation and rapid ice shedding would also be part of the mechanical pressure as well. Now, insulators with line posts, struts, and pins are unusual in that they may be subjected to a combination of cantilever, transverse, as well as tensile forces at the same time. And damage caused by impact or contact is also possible. Rolled salt, freezing rain, and snow accumulation on the insulator surface in some locations can cause flashovers, which can lead to insulator dielectric failure. Electrical flashovers can harm porcelain and composite insulators from the outside as well as the inside. Now, insulator deterioration can be split into external and internal. Now, external insulator deterioration can be easily detected with a visual inspection. So we should look for something like broken porcelain from a flashover or lightning, or impact damage such as vandalism in the shed. We could also look for burn, arcing damage, galvanizing caused by flashover burn patterns on the porcelain shed. Now, in regards to internal to the porcelain shed, latent damages to metal fittings and hardware would include things such as lightning flashovers or line galloping induced internal cracks under the metal cap or within the porcelain head, causing electrical shorts in the insulator and distorting the insulator strength's voltage profile, or something like radial cracks in the porcelain shed, which is mostly due to cement development. A glass fiber reinforced rod is usually covered in either EPDM or silicone rubber weather shelters with appropriate end fittings to make composite insulators. While composite insulators provide a wide variety of mechanical strength and are far lighter than other forms of insulators, the EPDM silicone rubber substance is actually soft and readily cut, ripped, or punctured by sharp objects, and the sheath and weather shelters must be in good working order. Moisture getting into the glass fiber rod region is a common cause of failure. Cuts, splits, holes, erosion, tracking, or burning of the rubber shed and sheath material, as well as separation or degradation of the rubber sheath material where it meets the metal end fittings, are all visible damage to the insulator. Any evidence of a power arc, lightning damage, or corrosion on the metal and fittings indicates that the component is deteriorating. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the Double E Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important, and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I have also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.